Hello everyone. This video is going to give you instructions to help you in completing Lab 2. I think the lab packet itself does a pretty good job of walking you through step by step, but this video is here just to give you a little bit extra. The first thing you should do is download and or print the lab packet. Once you have it, you should read through the introductory remarks. In particular, these pertinent facts will be used later in the lab. The equipment required is a computer to do the simulation. The conducting paper and the conducting ink pen will both be part of the simulation. Section 6 explains the experimental procedure. You will have to go to this website to view the interactive. Once you're there, these steps show you how to do the experiment. And once you get to 6.1, we actually start the experiment. In this part, we will be drawing the equipotential lines in the region between two electrodes. The parallel plate capacitor is fairly straightforward, so I will leave that to you. Just make sure that you draw the lines all the way to the edge of the paper. The cylindrical capacitor is a little trickier though, because we have to draw curves, so we'll look at that one. We want to start by drawing the pattern and selecting the 2.5 volt option. So we switch over to our simulation. We will expand it to fill the full screen. We're going to change the grid size to increase our resolution, and then I'm going to select the 2.5 volt option. So then your grid should look something like this. Now notice that I can really only draw horizontal and vertical lines that look correct. If I try to draw a diagonal, I'll get something that looks maybe like this, and that's not connecting and it doesn't look diagonal anyway. If I try to draw a curve, I'm going to get something that doesn't look like a curve. So for those things we have to adjust the diagram a little bit. The cylindrical capacitor has one big outside ring and then a small dot in the middle, and the closest I might be able to get to that is this. I have one big outside ring. I have tried to make curves around the corners as best I can. The outside ring is as symmetric as allowed, and then I have one dot in the center. Okay, so once I've drawn the pattern, I'm going to connect the probes. The positive is going to go on the outside and the negative on the inside. And then once my probes are connected, I'll have a play button in the bottom right corner. Once you hit play, you'll notice the numbers start to change. Okay, so these numbers represent the potential at the different points on this grid. And what's happening is the simulation is releasing positive charge from the positive electrode. That charge is, generally speaking, making its way toward the negative electrode. Now, it takes a little bit of time for this simulation to fill out all the numbers, so you're going to have to let it sit for a minute. Let me fast forward for you. Now, once the numbers have stabilized, I'm going to start by looking for the 10 volt equipotential line. If I start in the center and I move up, you can see that the numbers increase. In the center of this square right here, we have a potential of 9.7 volts, and then one square up, the center of this square is 10.7 volts. So 10 volts is somewhere between these two, and I will guess it's right about here. So roughly 60% of the way up from the center. So then I'm going to go back to my lab packet, or wherever you're drawing these figures. You may have to draw them separately if the lab packet is too small. I'm going to make a mark to represent that 10 volt spot. Then I'm going to go back to my simulation, look for the next 10 volt spot. This point right here is at 9.9. This is very close to 10, so we'll just consider it to be 10. Notice that it's one grid square to the left, and it's going to be a little bit lower than that 60% spot that we picked for the first one. So I go back, I draw a dot to represent the next 10 volt point, and then I repeat. If I go back to the simulation, I can see I have a 9.6 here, A little further out is 11, so it's going to be a little bit further than the 9.6. We'll say it's right about there. And then you keep doing this for all the points in the simulation, or at least enough until you see the pattern. So if you draw a couple more, you'll notice that it's a circle. So then you want to connect all the points. And we'll call this the 10-volt line. Now that we're done with the 10-volt line, we want to do this again for 8. So 8, you can see, is about 40% of the way up, maybe a little lower than 40% of the way up. So do that for the 8-volt line. The 6-volt line is a little above this first grid square. The 4 and the 2-volt lines are going to be tricky because they're packed in here. You can see that both the 4 and the 2 are somewhere between the center dot and the first grid square. But in any case, you go back to your lab packet, you draw the 2, 4, 6, 8, and 10-volt lines. Make sure to label everything so you can keep track of it later, and then you're done with this figure. Let me warn you that in some of the later figures, the equipotential lines are not as easy to see the pattern. So for this one, for instance, you won't have a simple circular or square pattern surrounding this central conductor. So you may have to find more points to determine where the equipotentials actually are. Once you're done drawing all the equipotential lines, you can move on to the questions. Question 2 down here is regarding the cylindrical capacitor. So based on the pattern of the equipotential lines you've found, you should be able to determine some things about the electric field. For example, the direction it's pointing, whether or not it's uniform, which part of the electric field is stronger. And once you've answered those, you can then go back to the simulation and switch to the electric field option. So in the bottom left, you have the electric field instead of the potential. If you switch to that, you can see what the electric field looks like. And now that we can see what the electric field looks like, you can use that to determine whether your answers to 2 and part A were correct. Okay, so then you're done with 6.1. You move on to 6.2, where you repeat the procedure for this figure with the square conductor in the center. You find the 2, 4, 6, 8, and 10-volt lines and then answer these questions. 6.3 is a little bit trickier because these shapes are a little bit more difficult to draw. For the sharp point, for instance, you may end up with something that looks like this. But in any case, do your best to match the shape on the lab packet to what you can get on this square grid. Once you do that, you find the 2, 4, 6, 8, 10-volt lines and answer the questions. And then you move on to 6.4. In 6.4, you'll use what you learned in the previous parts of this lab to speculate as to the shape of the equipotential lines and the lines of force for these 3 figures. Okay, and then once you've guessed what you think it should look like, you can check with the simulation to see if you were correct. And then you move on to the final part, the analysis and results. If you've been following along, then you've already completed number 1. For number 2, you draw the lines of force that correspond to the equipotential lines that you have drawn. In 3, you want to check back with the general statements from the introduction to see if they match up with your results. And then for 4, draw the direction, draw arrows on the lines of force to represent the electric field. Note that the equipotential lines do not have arrows. And then finally, just reread through those pertinent facts listed back in the introduction and see if they agree with your results, or see if you applied them throughout this experiment. and then you're done. The last page here is just a space where you can put your drawings. So you can draw them here if you print it out, or you can put them on a separate piece of paper. That's fine as long as everything gets uploaded. And that's all I have for you. So good luck with the lab, and if you have any questions, let me know.